Here we go. 5-4, day 2. Yep. Okay, like I said, we're going to marry together that NCDF stuff with the sampling distributions we did yesterday. So we're going to be finding probabilities. Probabilities when taking samples size n greater than 1 from a population. Okay, so finding a probability is finding the area under that normal curve, and what function on the calculator gives us that area? Review. And normal CDF. What do you feed NCDF? Z-scores. What order? Z left to Z right. Now, if we're taking samples greater than 1, remember that if the population was not normally distributed, we had to have samples of at least what magic number? 30. If it was from a normal population, we could be under 30, but the standard deviation changed. So we need a formula to change our sample mean into a z-score. The sample mean has to get turned into a z-score. And it's the same formula we had before, where we took the x value, subtract the population mean. Here we're going to take the sample mean, subtract the population mean of the sampling distribution, and divide by, how did we get that standard deviation yesterday when we took more than 1? Standard deviation divided by square root of the sample size. So the only thing that's different about this formula is that new standard deviation. It's now standard error because I'm taking more than 1. So, just having some examples.
Is the first example short?
No.
Wait, this is all we're doing.
This is it, marrying the two things together. So then, when the test comes around, it's going to be, boy, do I do this divide by the square root of the sample size thing? Every time you're taking more than 1, you're going to follow this formula. So, the mean time spent reading the newspaper is 33 minutes with standard deviation equal to 4 minutes if you are ages 45 to 65. You are going to take a sample of 35 people. And then I'm going to ask you some probability questions about those 35 people. Okay. Do I know what shape the population is for the reading time spent by these people ages 45 to 65? Did it say it was normally distributed anywhere in here? No. I have no idea what shape it has. I don't know. Okay. No idea. Didn't tell me. But it did tell me the mean is 33 minutes and the standard deviation was 4 minutes. I'm going to take a sample of 35. Well, if I repeatedly did that, samples of 35, samples of 35, and then averaged up the time, what happens to the shape of the sampling distribution according to the central limit theorem? It becomes normal. What's the average of this sampling distribution? Exactly the same as the population. The mean doesn't change. But the standard deviation for this group of 35 people does change. How do I get it? Four divided by the square root of the sample size. Okay. So now that we know what the distributions look like, I can ask the probability question. What's the probability that your 35 people have an average reading time between 30 and 34 minutes? So this is my sample of 35 distribution here. I'm looking for my 35 people to have an average between 30, I don't really quite know where it's at, I just know it's below the 33 here, and 34. I want this part of this normal curve. What am I going to have to do? Got to get z-scores for 30 and 34 so that we can feed them into the NCDF. So we need the z-score for a 30-minute average. So I do 30, subtract, what am I subtracting? 33, the average of my graph. What's my standard deviation of this graph? This is my standard deviation, and not over here, because this would be if I was taking 1. 4 over the square root of 35. Okay, I suggest you try this on the calculator. I can't tell you how many people mess up just using the calculator here. So try it. Work this out on the calculator. People mess this up continuously. Because they just write down the answer I write, and then when it comes to the test, they've never actually done one correctly, and they get them all wrong on the test. Swear to God, I've seen it. Negative 4.44. If I go z-score, so my graph is bad. It's actually way back here in the tail, but that's okay. Negative 4.44 z-score. So that's actually way back here. Not that you have to change your graph at all. And then the z-score for 34. Oh, did you get it? Any problems? I forgot to even ask. See how I use parentheses? I did it all in one line, parentheses around the numerator, and then I did parentheses around the denominator. Otherwise, the calculator just divides by 4 and then multiplies your answer by square root of 35, which isn't what you want. All right, so the 34, same thing. 34 minus 33. We've got that new standard deviation because we're taking more than 1. And then if you're real tricky, well, not tricky, clever, you can go second entry, retype the line, and then I just gotta turn that 0 into 4, put up. Little time saver. So I got 1.48. And then I still have to find the probability. Where do we go? NCDF. My left z-score is a negative 4.44, and my right z-score 1.48. pretty high probability. 0.9306. Good? I just have 3 examples today. Okay, number 2. We've got the average home price in the U.S. This is old data, but we'll go with it. Is $125,700. With standard deviation $26,000. Home prices are normally distributed. You are going to take a sample of 16 homes. And then we're going to ask you some probability questions. A probability question. Okay. I like to have a graph of the population that it's coming from and then the sampling distribution. What do I know about the population shape? It is starting out normal. So these home prices are normally distributed. They gave me the mean, 125,700. Standard deviation, 26,000. So my sampling distribution, do I have to hit that magic number of 30 from yesterday's central limit theorem? Central limit theorem said if it was coming from a normally distributed population, you don't have to have that magic number of at least 30. You can go smaller than 30. So I'm going to take samples of 16. What happens, it's going to be normally distributed, but how's it going to be different than this graph? Still normal, but what? Remember? Narrower. The standard deviation is going to get smaller. Samples, this is my 16 home distribution. So what do I know the mean of that distribution is going to be? The same. So 125,700. My standard deviation here is not going to be the same. How do I figure it out? $26,000, then what? Divide by square root of 16. Okay, my one question. What is the probability that the average of your 16 homes is less than